All right, we're going to get started if you want to sit down. Does this work? Yeah? Okay. It's part of the problem. Okay. For those brave few who stood around for the last panel or the last presentation of B-Sides, we are going to try to do something a little different. We're going to learn a little bit, hopefully, about IP6, talk a little bit about IP6 and various flavors of security, and then at the end you'll get to test your IP6 knowledge for drink or prizes, whatever you prefer. So if you think you know IP6, you don't know Jack. We have a great panel of most of the vulnerability management space here. Starting here on my left, immediate left, Tim Erlin is the Director of Product for Encircle. H.D. Moore, CSO of Rapid7. Wolfgang Kandik, CTO of Qualys. And Ron Gula, CTO, CEO, founder of Tenable Network Security. I also want to mention that every single one of these companies up here have sponsored B-Sides. So give them a hand for that. And we're going to go from here. Okay. So IP6 is something most of us have heard about, I assume. I don't know how many of you have actually dealt with it or think you have dealt with it or think you haven't dealt with it, whether you have it in your network or not. But it has the potential to really change the way you're going to do security and the way you're going to manage your networks, both at home and at work in the years to come, if you believe people that say we're running out of IPv4 space. The classic example is doing a discovery scan in an IP6 network can take a couple of trillion years, so we need a better way of doing it. What we're going to do is each of the panel members are going to give you anywhere from like a 4 to 8 minute kind of background in a particular area, and then we'll come into what we call IP6 Jeopardy. Leading us off will be Tim Erlin from Encircle, who's going to give us some IP6 general background. Tim?
All right. So I think that I may have the toughest job of the panelists in giving a background talk to an audience like this. So I'm going to start by just trying to get a little context from you guys so that we know our audience a little bit better. We can tailor the conversation and the questions ultimately to the audience. If you don't mind, I'd like to do a little show of hands exercise. So how many of you out there have actually been involved directly in deploying IPv6? Panelists don't count. A couple. How many of you work for an organization where there's an IPv6 deployment that's active, deployed now? A couple. Shh. We're not there yet. We'll go with deliberately for the time being. All right. And I'll make the assumption that the rest of you are here because you didn't answer yes to the first two questions and you'd like to learn something about it. So IPv6 is interestingly, it's a fairly old standard in many ways, more than a decade old, yet somehow still in its infancy. It's something that has been making progress lately in the past couple of years, I would say, measurable and interesting progress. To sort of, as a point of context there, if you're familiar with the IPv6 World Day project, the Internet Society, a consortium of large organizations and some small ones, got together in 2011 and did this IPv6 World Day project where they wanted to test turning on IPv6 on the public internet, find out how it went. These are companies like Facebook and Google and Comcast, and about 1,000 others actually participated in the end. And it was in many ways a very large success for IPv6 and for those organizations. So much so that they followed it up in 2012, this year, with what they called IPv6 World Launch Day. And they called it World Launch Day because they decided that instead of doing another test, they were actually just going to turn it on and leave it on, based on the success of the previous year. And there were about 3,000 organizations that participated in 2012, with also measurable success. Many of those organizations, if not all of them, continue to provide V6 services and V6 availability today. Just as a, to give you a sense of how much that is, we say 3,000 sounds like a lot maybe, but if you look at the traffic that the Dutch Internet Exchange, for example, they publish some statistics. They count about 0.5% of their traffic as being solely IPv6. So 99.5% of it is still IPv4, they have some mix in there for tunneling, things like that. So it's not a large percentage. It's still very small, but it's consistently growing. Of course, in that context, we're really only talking about the internet with a capital I, things that are measurable. It's much harder to measure IPv6, the prevalence of IPv6 and deployment, deliberate, inside organizations, inside large organizations and small ones. From my perspective, my background, when I talk to customers, I get one of three answers. When I ask them about IPv6, are you deploying it? Do you have a project? One of the answers is yes, absolutely. That's a fairly rare answer. Not uncommon. I would say a significant number, but not significantly large number. Many customers answer with there's a project, it's someone else's, it's not happening yet, it's in the future. You can keep in mind for context that most of the time I'm talking to information security folks within the organization. And then a large number of customers reply with a very simple, it's not on our radar, it's not something we're doing. Occasionally it's not something I need to worry about, which can be a little disturbing. So we see this sort of split between activity and press and publicity publicly and the internal deployment mechanics and progress for large and small organizations. And that's really where we are with IPv6. In terms of security specifically, we know what some of the challenges are. We don't know what some of the other challenges are. And the unknown unknowns, as is often the case, are the ones that might be the most concerning. And in order to dive into some of the detail there, some of the interesting points, I'm going to hand it off to my other panel members here. And I think I'm handing it to Ron next. Wolfgang.
Okay, I got it. So yeah, good evening. Thanks for the intro, Tim, for the IPv6. Did you have the slides up there? I actually prepared a couple slides for you. It's about a site that I have where I'm listing a couple of IPv6 configurations or tutorials that you can run to become more familiar with it. So if you're already running it, that's fine. There's nothing new here. If you've never done it, it's actually pretty easy to do, to become acquainted with it, kind of take a look what works, what doesn't work, how easy is it, how could you run it in your home. Those are kind of the ideas, and maybe how can you use it on a daily basis. I'm not really a networking person, much more of a system admin. So you got to take it with a grain of salt. But normally I think if I cannot make it work, which happened a couple times, it's pretty sophisticated and needs much more than you could possibly get when you want to actually use it at home. So there's 3 chapters in there. One is simply build an IPv6 network in a virtual environment, get a machine that can run a couple virtual operating systems. We're starting with Linux and integrate some Windows into it, then have another Linux box that routes out to the IPv6 internet, and then you can play a little bit with it and kind of browse the internet through IPv6. Another one is running an IPv6 server on, in this case, Amazon. That's also fairly simple. You can just get it could be a free server, a micro server works, run Linux on it, install an IPv6 tunnel, and then you have a machine that can actually serve pages under IPv6, and that machine is that actually. And the last one is then at home. So yeah, let's go to this next one here. So that's kind of how this starts. It's 2 Linux boxes, A, B. You can then ping between them, SSH between them, run Nmap, run Apache, browse to the page. Can you go to the next one? Then you put a Windows box in there, and it's pretty much the same thing. You get an IPv6 address, and you can just browse along. So it's actually pretty transparent. Next step is then adding. Can you go one more, Al? You're adding another box in there that routes out to the internet through. It has an IPv4 connection, which is what most of us have at home or at work. but it tunnels over an IPv6 tunnel. And that's pretty stable, works pretty well, and it's actually pretty easy to set up. So maybe 4, 5, 6 hours of work to get something like that up and running, and I think you'll gain some pretty good experience by doing something like that. What else? Yeah, the other one is an EC2, get a machine there. A micro machine is free if you sign up for the first time for a year, so it's very low cost. Request an IP, a V6 tunnel, set it up, and you're done. You basically have a machine that can serve out pages on IPv6, and you can play around a little bit with it and see what some of the pitfalls can be in terms of security, because now you're running two protocols. You're running IPv4, IPv6. The Amazon firewall only does IPv4. So you have to do this by yourself. At home, I've looked into a bunch of routers that would do this. This is a D-Link. Then really nice one. I mostly bought it because it kind of looks kind of nice. What else do we have? We have an Apple Airport Express. You can't even see that thing under the white background. And then an old Linksys that runs custom firmware for IPv6. That's the ranking right now. So the D-Link doesn't work for me at all. The Linksys works pretty well with that firmware. It's, but you need to do your custom firewalling. And the Airport Express works actually really nicely. Has an IPv6 firewall up. It's a little dicey. You need some older management software to get to it. The newest version doesn't have it anymore. Apple dropped it. They got a lot of flack for that as well. But that actually works pretty well. So that's the site, IPv6experiments.com. It runs on that Amazon server, accessible through IPv4 and IPv6. So, and any feedback, send it to me or send it to feedback there. I'll get that. And happy to integrate something. If you have a home router that works really well, we could definitely put it up there. So right now, my vote is kind of for the Apple Airport Express. That seems to be giving my family the best IPv6 addresses. And we now access whatever is accessible on IPv6. So next project for me is kind of measuring that and see how much is that. Is that 0.5% for my particular case or more? So I appreciate if you take a look at the site and give me some feedback to see if it actually is helpful or whether it's too slow or too fast in terms of progress. So that was still intro. Vulnerability management. Well, so we all do have products that work in that area. They all are IPv6 enabled. That means you can scan an IPv6 machine through that and see what are the vulnerabilities that are there. It should be transparent, meaning this will work just like everything else, but there's gotchas here and there. I think for the basic vulnerability scanning, it's actually not too difficult. It works pretty well. We don't have, and Ron just kind of said the same thing, we don't have that many customers actually doing this. Some are forced to do it by compliance requirements. We hope that because of the IPv6 World Day, people implement it more and that it will get more coverage. But right now, it's a fairly low on the priority list. So I would say it works. Major problems are actually more on the management side. You used to deal with IPv4 addresses, and everybody, you can even almost remember them, and that's kind of difficult on the IPv6 side. Make sense? Okay. HC or?
Yep, it looks okay. So I've got a slightly different view. I won't go into the vuln management side so much as the pen testing side. I've been working at Metasploit forever. We looked at doing Metasploit v6 support about 3 or 4 years ago, and we got pretty far along with, actually 4 or 5 years ago now, pretty far along with payload support, basic library support, things like that. It all worked fine and dandy as long as you know which machine you're attacking and you've got payloads configuration to get there and so on. So there's lots of fun headaches involved with v6 too. One thing that very few people take into account, and this will be part of a trivia question later on, is that some OSs handle v6 differently for different services. You'll see that if you take a machine and give it a v6 address and scan it, and then a v4 address and scan it, you'll get a very different profile of open ports. Sometimes it's actually more, sometimes it's less for each service. Windows is notoriously bad about having less services on v6 than on v4, which surprises me when I looked at it. You do get a couple new services with 7 and 8 that only show up in v6, but that's a different story. But typically, you actually have less of an attack surface on v6 for Windows operating systems than you do on other platforms or other configurations of v4. However, on Linux, you actually see more vulnerabilities open on v6 than you do on v4. It's a fun kind of odd issue with how things are, what services bind to what protocol adapter, basically. So the thing I really want to say about pen testing in v6 is if you're doing there's really two forms of pen testing. There's testing your local network for v6 addresses, the link local addresses. That's very effective these days because any appliance you buy, any system that's Linux enabled by default, will have a v6 address and usually not a v6 firewall. So if you buy, random virtual appliance from some vendor, or you plug your I won't say the name, you plug your device into a local network, and you happen to have a local v6 address, you can now do terrible things to that machine to its v6 address and not its v4. And that makes a lot of assessments of these devices much easier if you're locally on the same LAN as the device because you bypass the firewall for it. So keep that in mind when you're doing testing. If you're doing remote v6 testing, the biggest problem there is finding the damn thing. It's saying, okay, I found one box, now what else is out there? And there's all kinds of really crazy, hacky v6 implementations. There's one proposal by Virginia Tech that says for every connection your machine makes, we're going to use a different IPv6 address. And no other IP is valid for that particular pair. So because every host is given a fairly large chunk of addresses, there's no shortage of IPs even for a single machine. Now keep in mind that a single machine can have multiple v6 addresses per machine, per interface at the same time. There's no one IP, one machine, one NIC. You can have 1,000 IPs on the same NIC, on the same box. And if you don't test them all appropriately, you're going to miss something. So the complexity level of doing a valid v6 pen test has gotten pretty difficult when things are in these kind of extreme situations. But in the short term right now, all you really have to remember is follow DNS, look for sequential IPs in the low-end ranges of v6 blocks. And if you have a machine on the local v4 network, try to find its v6 address and then pound on that because you often find better ways to break in. And even if you break into one of those machines, the admin's going to be really confused when they see last login from FE80::, something or other. Like, what the hell is that? How did I get owned by something alphanumeric? So anyways, it's a fun time to be doing v6 pen testing, but right now it's only mostly useful on the local LAN.
Thanks. All right, and just talking about some of the security operations in relation to IPv6, there's a couple things going on. Most of the organizations I'm seeing out there, their attitude for IPv6 and where it is on their radar, it's not very high. They're much more worried about the cloud, about mobile. I even, like at our booth today, I was like, hey, you worried about IPv6? No, I'm worried about IPAD. They're worried about the mobile devices and things like that. So having said that, I mean, IPv6 just adds a lot of complexity to whatever you're doing, whether it's compliance or incident response or different things like that. And it's just not something that people are really prepared to go ahead and do. But there's really two things I want to address. One is just kind of how does this impact compliance operations, so to speak. So no matter where you're at, you're impacted by compliance, whether you're in the government and cyberscope, or it's a DISA kind of thing, or it's a PCI kind of thing. I have not seen IPv6 show up at all on those things. So if you're a typical large federal government organization, you're scrambling right now to do a monthly end-to-end scan of your entire network, and this is for something called cyberscope, right? CVEs, CPEs, CCEs, all with IPv4 addresses. They don't have any sort of notion of IPv6 or anything like that. And then the second thing is if you're more on the commercial side with PCI and whatnot, there's just not a whole lot of knowledge out there of, do I need to scan for IPv6? Is it part of my assessment? Even though a lot of times if you do have an IPv6 internet-facing device, you can go right past the firewall and so on. But the next thing I want to address for IPv6 is even something HD was just talking about, just how these numbers look and how these addresses look. The open source community, the vendor community, the services community is not ready for that. So if you have a network-based anomaly detection system, for example, there are probably tons of smart PhDs working on that who've developed IPv4 32-bit hash tables to do these things. When you start just going into the IPv6 address space, not even talking about some of the cases that HD was talking about, just handling that kind of bit thing, you really don't have the CPU or the memory to kind of keep up with those things. So I don't know, I'm not going to name names, but if you're an anomaly customer or a SIM customer or anything like that, and you're like, oh, hey, show me the report of the number of hosts that connected to the botnet. Well, if you actually get a larger number of addresses on the inside of your network, that's just not going to happen. It's not going to happen. And then certain things, even outside of the SIM or the IDS space, if you just want to say, hey, hey, report the number of hosts, show me these assets, just give me a list of IP addresses, right, that are out there on the network. Things like the GRC systems, the asset management systems, and those kind of things, they're really not in tune to handle these large numbers of IPv6 addresses and so on. So all that is basically kind of, in my mind, we're not ready for IPv6. If it is here, and we'll probably talk about this in a little bit, it's snuck in the network and so on. I haven't really seen any major hacks that leveraged IPv6 exclusively. Most of the big hacks that are out there, I don't think IPv6 was a factor, but it's coming. It's definitely coming. So with that, I think we've got IPv6 Jeopardy. Yes.
Okay, so we're going to try something called IPv6 Jeopardy. Here's the. You got it? You got it? Okay. Actually, your questions I have here. Here are the questions. Yeah. Just, I might. Whoa! Okay. Hold on, we might have lost it.
Lost its IPv6 address was now.
Yeah. Did you see anything for now? Hold on. All right, so we're going to do a little IPv6 Jeopardy, if I could see what we're doing here. I think we deleted them. Oh, well. Hold on. Yeah, we're going to... All right. Close. I think we actually... Yeah, look at that.
How is that possible?
I don't know. Hold on. We'll find it. No, it actually deleted. Son of a gun. Anyway, while we're looking for this, we're going to do IPv6 Jeopardy. What we're going to do is this. Obviously, we have the 4 people. I have red tickets here. Each red ticket you can take to the bar and put it on my tab for a drink. You get the question right, you get the red ticket. Obviously, as we go up from 10 to 20 to 30, the questions get harder, but you'll get more red tickets. However, like in real Jeopardy, you get the question wrong and you give me back the tickets. And the boys here know as many tickets as we have at the end of the game, we get to drink. So it's us against you. I'll take volunteers from the audience. If you feel man or woman enough to raise your hand, pick a category and a denomination, we'll get started. Tim, okay, we got one right here. Go ahead. HD Moore for 10. You got one? Go ahead, man.
How many bare nipples are on the ceiling of this room? In terms of an IPv6 net mask. I'm kidding, actually, it's a softball. The real question is, what is the default consumer bit mask size, and what is the default operator organization bit mask size provided by most IPv6 ISPs and tunnel services? That's the easy one.
That's a softball?
Yeah.
I don't even know that.
It's easy. When your tunnel interface, type ifconfig. Look. Kidding. Sorry. I could try to find another softball you want. How many noses are... I'm kidding. Let's see. No.
Give us a ticket.
You don't have an answer for that? So if you go to tunnelbroker.net, and you can do this while I'm talking if you're really quick, and get an IP address, get an IP allocation, then what do they give you if you're a consumer versus what do they give you if you're an organization, and what's the difference? Close. Like, shift it to 16 bits, one way or another. All right, I think we got a half answer. Does that count? Do you get a half a ticket and you got to put the other half together? All right, that works. So the answer is actually they give you a 64 for a single consumer, and they give you a /48 for an organization. So sorry about that.
Who has the... All right, that stinks. We really lost that one. Go ahead.
So does that make sense? /64/48? /64 means you can, well, put a boatload of machines in there, more than I can count. /48. Yeah, more than, I don't
It's
know.
the current internet times the current internet is a /64.
Okay, so that's pretty big. That's what you can have at home. /48 means you have 65,000 and something 16-bit subnets that you can have with that type of thing. So it's pretty big. People think we'll never run out of it.
We'll try.
We'll try it anyway. So
I remember when we weren't going to run out of 40 meg hard drives. All right, next, anyone else taking a crack? Tim, come on. Tim for 10.
All right. My 10 will be significantly easier. How many bits in an IPv6 header? 6. Thank you.
All right, Tim, get your drink. All right, you see, we didn't make them all hard. All right. Who's next? Who's our next contestant? Jennifer, JJ. Oh, come on, come on. Take one. You got to take one when you're on the spot. He's working. All right, you know what? Who's that guy back there with the glasses sitting in the corner? We'll get him. Take one. Pick one. Which category you want? Ooh, ooh, ooh. That's a guy with a pair right there. Okay. Oh, go ahead. Oh, here, you need the mic.
Try that. Let's get talking about that one. That's like we haven't really talked about
how difficult is that one?
yeah.
Okay, so conceptual question. How difficult is it to map an IPv6 network? Very good. A little more maybe because it's a big drink. So it's really big. That takes a long time to map. But HT gave a couple pointers. He said most organizations will probably allocate addresses kind of in the lower bits. So they start with 1 and give the next machine a 2 and so on. And so you can cut down on the search space, which is enormous, again, internet times the internet or something like that, by being smart about it. So brute force scanning is going to be very, very slow. Smart scanning, you can still be much quicker than and probably finish in time. So focus on the low bits, first 1,000, or if you found a machine, look around. Many addresses also depend on the MAC address of the box. So if you know they use here Qualys, we use ThinkPads, you have a pretty good idea what the first 3 octets are of that. So they show up, you don't have to scan for that. So you're cutting down on the search space by being smarter about it. The brute force scanning is going to be complicated.
Good answer.
Good answer. It's complicated and difficult.
All right. Anyone else? This gentleman knows about IP6. You've had your hand up twice. So now, take a category. Going for a mid-level Tim for 20 question.
All right. All right. Let's see. Are IPv6 headers in the packet larger or smaller than IPv4? What was your answer? You are correct.
Very good.
Would you like the follow-up question? Well, actually, it's not really a follow-up question. Oh, they're larger. The answer is they're larger.
Tim for 30.
Yeah. And they are larger, but actually more efficient to process, and that's one of the advantages of IPv6. And they are more efficient to process for a couple of different reasons. So they've removed a bunch of the sort of optional header fields that don't get used very often, and there's no longer an expectation that the router will actually calculate TTL, so that calculation is taken out. And there's one more. Oh, no fragmentation, of course. So there's essentially no fragmentation in IPv6, at least in terms of routing, and that speeds it up as well.
Okay. Oh, he's going Tim for 30. Oh, no, you don't want Tim?
No? Oh. A hard one. Well, let's just follow that up with how does IPv6 handle packet fragmentation? Or not handle it, as the case may be. Oh, he's giving the ticket back. So sad. Well, as I said, it doesn't. There's no fragmentation. So basically, there are two ways to handle it. First of all, there's a process called path MTU discovery, where there's a method of discovering the MTU for the path that you're traversing so that it gets set correctly, and that way the router doesn't have to deal with any fragmentation. Or it is possible for the endpoints to actually handle the fragmentation, within, to use the, there's a minimum MTU that you can use as well. But the path MTU discovery is the one we're after there.
So how do you fragment then?
Oh, you don't. That's...
You don't fragment. Somebody has to fragment. All these things have to fit in. So endpoint fragment. So the applications actually have to fragment. Yes. Or the higher levels of the protocol actually are now in charge of making sure that the packets are not too big, I guess.
Disagree. You can fragment IPv6 just fine, and you can bypass RA guard using IPv6 fragmentation.
Okay.
I was just going to say that IPv6 is a bit like a teenager trying to push responsibility onto everybody else, but
So what HG just said is totally true, but it's kind of like, when you went to grammar school and they told you 1 + 1, you can add numbers, and then they told you they're negative numbers, and it is all a new concept. So the truth is, you go up and down the stack, there's always things that you can do if you go one layer lower than what most people think about. And you can do amazing things there that just slip by, security mechanisms, evasion technology. There's a lot of stuff. All of a sudden you talk to networking people, they will tell you, no, you can do that stuff, where you thought, no, that's not possible. So that's the answer.
So fragmentation works today, but it's not going to work in like a year because every vendor is basically killing fragmentation from the RFC at this point. So there are ways to do terrible things through fragmentation headers, but as all the vendors find out that their solutions are terrible and don't work with fragmentation, they're getting removed one by one from the spec. So we're both right in different historical timelines.
Excellent. So got into parallel universes there. So Tim is done. Wolfgang has only 1 or 2 left, but no one's asked Ron a question. Who wants to ask Ron? Ron for 10.
All right. Are IPv6 packets encrypted?
IPv6 has security built-in.
Maybe very secure.
I don't know. Don't ask him. You said no? Very good. Here you go. We got a winner. I'll give him half a ticket. That's okay. You did good. Congratulations. See, there are winners out there. All right. Very good. All right. Who else? We have a few more. You want to do a follow-up? You're on a roll. Double or nothing, baby. Here we go. Come on. Come on. Ron for 20. Okay.
So there's more bits in IPv6 packets, right? But for TCP and UDP ports, are there more ports as well? No. Correct.
Correct for 20. Here you go. You want to push it? Double or nothing? 30?
Round 30.
All right, here we go.
Come on, baby.
Can you have an e-com?
Hold on, new dealer. Let's change the dice. No, go ahead. Holy cow. Go ahead.
All right. If you have an e-commerce site that's PCI something to PCI, but you've got an IPv6 address hanging out there with 0-day, PII, and stuff like that, can you still be PCI compliant?
Yes.
I would have accepted either answer, but
Okay, very good. Here, take 2. All right, we got a big winner. You're going to keep rolling. All right, HD. Let's get the. He's got all or nothing.
All right. That's a good one. Now, this one's easy. If you ever actually...
Coming home, baby.
All right. On Windows XP Service Pack 2, with no patches applied and IPv6 enabled, what exploits work and which ones don't work? And you only have to give one example of one that normally works and doesn't, and does work anyways. And nipple counts work too. So
All right. Anybody know all the framework packages? Let's go through this. It's probably
Any exploit works. It doesn't have to be a Metasploit. It can be any kind of exploit out there. Sorry. So MS-8067, did you say that works or doesn't work on V6?
doesn't work on me.
Why? Which one does work and why? So we're halfway there. So the freebie answer is MS-8067 does not work on Windows XP SP2 on IPv6. But it should. Why doesn't it? And if you can get that and you can get an example of a working exploit, yes, sir?
So that's one of the ports that Windows actually buys.
Yes. That the NetBIOS service does not bind to V6 addresses in XP.
Excellent. Excellent.
I think you win that ticket.
Any RDP exploit will work. Any of the remote desktop.
The RDP, well, RDP, you're right. It will work, but it's if it does work, it will work. But the one that still works, though, is MSO3026DCOM. So you can still Blaster. So you can still use the Blaster exploit on XP2 boxes on V6, but you can't use the configure bug because it won't bind NetBIOS to V6. Really? Yeah, it's weird shit. So.
Okay.
How are we doing on tickets? Do we need to come back? Or
Yeah, we need to take some. No, besides tickets, I've got some other stuff to give away. Who wants an iPad? Not an iPad. Yeah, I wish. It's a new one. It's the iPad 4. It's going to be real. It's a 4-incher. It's a slider. We'll make it a real easy question. Anybody want to take a shot for this? All right. That was an easy question. T-shirt. You got an IP6 question for a T-shirt? Yeah, Wolfgang, you do it.
So T-shirt. Okay. What's the equivalent of ARP, IPv4 ARP in IPv6? What are we giving it away?
That was best answer all day. Who has it? What about this gentleman in the beard back here? We'll give him a T-shirt question. What would you rather? Do you have an iPad? You want a kickstand for an iPad instead?
Hey, come on, don't mess with Texas. He wins just because he's from my state.
All right. How about an iPad question?
Come on.
Who got a question?
I still have an open question.
Go ahead.
Texas, HP.
You want to give him the ARP question? Because we didn't answer it.
Yeah, I don't think we did the first one. So current percentage of IPv6 traffic on the internet, on the open internet. 0.5% is pretty good. What else? Any other guesses here? 0.5% is good. I think it's 0.75 right now. The measurements, the most recent one I saw.
And without the pornography? 0.
It goes down. Yeah. So I spoke to some guys from Yahoo the other day, and they said they have about 3% of their traffic is IPv6 already. So it's and they see it growing.
Oh, because of the connections of the partners. That's why.
Could be Japan, could be anything of like that where people kind of use it more in advanced mode, I guess.
So is it ARP network discovery protocol? Correct?
In V4, it's what's the equivalent in V6? NDP. Of ARP? No. Okay, give that shirt back.
It's NDP. What do you mean? You call it ICPv6, but it's still NDP.
IPv6, yeah.
Same thing, NDP. I'll
NDP?
give it back to him. Same thing. You can call it either way. Well, NDP is implemented on top of ICPv6. Okay. So it's layered, but Wolfgang is correct that it's ICPv6.
Normally you just do an ICMP. So I guess ICMP does much more in. So normally in V4, I think of it as ping. Right, but under V6, it does many more things. It discovers routers and discovers nodes and stuff like that. There's no more ARP. It's ICMP. Yeah.
All right. We got 120 question with HD Moore left. This gentleman over here, you haven't asked one. You want to do one? Him, no, behind. Actually, you two haven't either. Any of you guys, step up. You ready? If you're man enough, he's ready. All right, give him a 20.
In IPv6, what is a scope ID and what does it matter? Jordan, you have a question? Answer? Sorry? Scope as it applies to the socket call. When you're creating a socket, you have to specify the scope ID. And why does that scope ID matter with some types of shellcode? All right, so the thing is, if you're using a link local address like FE80 something is only valid on that particular interface. You can have the same link local address on multiple interfaces on the same machine. Yeah, it gets close. So you can have the same IP on multiple interfaces on link local. So the way they differentiate those is through a scope ID parameter on the socket call, which indicates which interface the socket should go through. However, if you're writing shellcode that's reverse connect on a link local IP, the reverse connect shellcode has to know the interface number that it's running on to be able to connect back to the machine on the link local network. So you have to guess a magic freaking number on a remote machine to make your reverse shellcode work on link local v6. It was an easy question. So. Oh, Alan wins.
Got it. It was an easy, yeah. That was a well-rehearsed answer. All right. We have a, what do I got here? An iPhone 4 case. Does anyone have an iPhone 4 case or have an iPhone 4 that needs a case? Yes. All right. Do we have any questions left?
What's faster?
What's faster? Manual or automatic?
I would logically say before, but I'm thinking.
Go counter.
Well, because
V6, because you dropped all the extra seconds.
that's why I was going to say, because all the extra crap with V4 is gone with V6, so I'm thinking V6 is probably faster.
Is that correct?
I'll say yes. I was also looking for less NATs, less firewalls. Right, we're all going to need one big network pretty soon, right?
Okay. I don't have any other swag to give out. I don't know if anyone else wants a drink. No, whatever's left over, we're drinking. I think that's going to bring an end to our IPv6 panel then, as well as an end to B-Sides this year. Guys, thanks everyone for coming. You guys put on a great show. Enjoy DEF CON. Are we going to have some closing statements, Chuck? Yeah? Come on. Well, yeah.
Thank you all. Thank you guys for coming. It's a fantastic wrap-up panel. Thank you all. This has been an outstanding event. The Artisan has been great. The shuttles are running a little bit longer. If you're headed back to Rio or Caesars, the route should be leaving the back where the shuttles run from here to Rio to Caesars. If anybody's headed to Toxic Barbecue, tell the bus driver. They'll run to the park and drop you off. But you need to find your own way back unless you are only staying for a few minutes. We're going to clear the place out and tear down because at 9:30 we reopen for the party. And the party runs until 5:30 in the morning. So if you're coming back over for the party, there will be a shuttle bus running from Caesars to Rio here, a nonstop loop, only one bus, but a nonstop loop from 9:30 this evening till 5:30 tomorrow morning. We have a stack of DJs and dual core are all lined up to start rolling. So at 9:30, we hope you guys come back. But thank you very much for participating. And since we have a team of sponsors up here, I'd like to thank you guys again because it's fantastic. Thank you very much. That makes it happen. And now it's time for the volunteers to earn their pay. Oh, wait, we don't get paid. That's right. We have $15 and a T-shirt. $15 and a T-shirt. So thank you all very much. As you go home, find the B-Sides near you and participate there. Thanks. We'll see you tonight.